Imagine a hurricane completely wipes out the regional power grid.
Right. It's just totally down.
Yeah. A traditional gas station down the street, well, they can just fire up a diesel backup generator, keep the pumps running, and get vehicles fueled up so people can evacuate.
Right. Because liquid fuel is right there in the ground.
Exactly. But if you drive an electric vehicle and that grid goes dark, you are, effectively a sitting duck.
Yeah. Completely paralyzed.
That is, of course, unless the charger actually comes to you. So today we are taking a deep dive into a really fascinating stack of sources to uncover this sort of hidden revolution that's happening in EV infrastructure.
It really is a revolution. I mean,
Right?
we are moving far beyond that cozy, settled image of just plugging a sleek car into a suburban garage wall overnight.
Right. And to show you exactly how this is playing out, we have a diverse stack to pull from today. We're analyzing municipal strategy meeting notes from Massachusetts, diving into the mechanics of a California legislative bill on emergency preparedness.
That's AB 2543, right?
Yeah, exactly. And we're also looking at corporate scaling announcements from companies like Pioneer Power Solutions and BeeCharged EV, and capping it off with this highly detailed tactical report from the NATO Energy Security Center of Excellence.
Which is just a wild read, honestly.
Totally. So our mission here is to extract the most critical insights from all these materials so you can see exactly how the grid is evolving.
And, the most immediate bottleneck for EV adoption across all these sources isn't actually range anxiety on the highway, like most people think.
Oh, like, what is it then?
It's the raw physics of urban density. I mean, if you live in an apartment building and park on a crowded city street, you just don't have a driveway.
Right, of course.
And tearing up miles of concrete sidewalks to trench high-voltage lines and build, brand new charging pedestals, that's just a non-starter.
Oh, the permitting alone would take years.
Exactly. Not to mention the astronomical construction costs.
So instead of fighting the city grid or waiting for this massive municipal overhaul, companies are getting highly creative with what is already bolted to the pavement.
Yes, and this is where it gets clever.
Like, in the Massachusetts municipal meeting notes, we see a company called VoltPost taking a radically pragmatic approach. They are literally retrofitting existing street lamp posts into plug-and-play charging stations.
I love this concept.
Yeah, they slide the shroud over the base of the lamppost, and it's equipped with retractable cables. But the most interesting part is how they actually manage the power draw. Because, a standard streetlight runs on about 100 volts.
Right, which isn't enough.
No, to get a level 2 charge, which is what you need to actually juice a car overnight, you need 240 volts.
So how do they get around that? Well, VoltPost handles it by working directly with a local utility to swap out the specific line feeding that pole.
Oh, so they upgrade the wiring?
Exactly. They step up the voltage locally, inside the smart post itself. And they manage this without taking electricity from the luminaire circuit, ensuring the streetlights don't dim when a vehicle plugs in.
That would be a major safety issue.
For sure. And a single upgraded lamppost can support up to 2 chargers on a street, or like 4 in a parking lot. Plus, they coordinate all of this at no extra infrastructure cost to the municipality.
It's like a brilliant form of urban symbiosis.
Oh, that's a good way to put it.
Yeah, instead of building a brand new coral reef, these companies are acting like remora fish, attaching their tech to the infrastructure that's already anchored right there in the environment.
Absolutely. And we see another version of this symbiotic approach with a company called It's Electric.
Right, they were heavily featured in the municipal notes, too.
Yeah. They deploy curbside chargers, but instead of tapping into streetlights, they pull excess electrical capacity, roughly 40 amps, directly from the adjacent private buildings.
Wait, okay. The logistical hurdle there has to be billing, right? I mean, if a public charger is tethered to a private apartment building's electrical panel, doesn't the property owner risk footing the bill for anyone who pulls up to charge?
You'd think so,
Yeah.
but the source data outlines their workaround. It's Electric utilizes a specialized software provider called Switch.
Okay.
And this software creates a sub-metering environment. So it essentially intercepts the data from the charging session and separates the charger's electron draw from the building's main load.
Oh, wow. So the software guarantees the landlord's monthly utility bill is completely insulated from all that public charging.
Exactly. And even better, its electric covers all the equipment and installation costs up front.
Nice.
And they actually kick back 20% of the charging revenue to the property owner.
Okay, that's a pretty sweet deal. And they also use detachable cables, right? Like the EV owner brings the cable with them.
Yeah, which is a really smart physical safeguard. It keeps sidewalks clear of tripping hazards and, prevents copper thieves from snipping cables in the middle of the night.
Which is a huge problem. But even with all this cool tech, the underlying physical technology is highly adaptable. It's the municipal notes that reveal the true barrier isn't engineering at all.
No, it's bureaucracy.
Always is. A utility pilot program by National Grid in Melrose, Massachusetts, actually proved that these pole-mounted chargers are 70% cheaper to deploy than traditional ground-mounted stations.
But 70% is
massive. Huge savings. However, navigating the third-party attachment rules is apparently a complete nightmare.
Oh, I bet. You have to survey every single individual pole for wind load capacity, right?
Yep, draft complex attachment agreements, secure annual licensing, and untangle all these insurance liabilities between the city, the utility, and the charger operator. It is just a massive municipal headache that slows deployment to an absolute crawl.
Right. And then, once the charger's actually installed, human behavior becomes the next wild card.
Oh, for sure. The notes from Somerville, Massachusetts provide a perfect case study on that. The city recently had to implement a fee of 25 cents per kilowatt hour for their public chargers.
And those were previously free, right?
Yes, totally free. And the goal wasn't even revenue generation. It was purely behavioral economics.
Because free chargers encourage drivers to treat the public spot as their personal parking space.
Exactly. They just leave it there long after the battery is full. So introducing a cost mechanism forces space turnover. And it significantly reduces casual vandalism by ensuring the infrastructure is, actively monitored and utilized by paying users.
Right. That makes total sense.
Yeah.
But if the bureaucracy of surveying lampposts and managing all these attachment rules takes years, and a city simply doesn't have the luxury of time, the fixed grid actually becomes a liability.
It really does.
And that introduces a massive shift in the strategy outlined in our sources. Because if bringing the car to the charger is delayed by red tape, the next logical step is to stop waiting on the utility company and bring the charger directly to the car.
Right. Mobile EV charging, it fundamentally severs that reliance on real-time grid connections. Like, look at SparkCharge. They operate a platform that delivers portable battery units to vehicles literally anywhere in a city.
Yeah, it's wild.
Costs fluctuate based on demand and location, obviously, but the source's site ranges from about 60 cents per kilowatt hour up to maybe $1.20 for larger freight applications.
Right.
But I have to apply a healthy dose of skepticism here looking at those numbers.
Fair enough.
We are talking about loading massive, incredibly heavy lithium-ion batteries into the back of a truck, driving that heavy truck across a city, burning energy along the way just to plug those batteries into another battery.
Yeah.
The physics of that just feel completely counterintuitive. I mean, it seems wildly inefficient for an everyday consumer.
Well, you're right. For a single commuter charging their sedan, it is inefficient.
Yeah.
The physical realities of energy transfer dictate that.
Right.
But the corporate and municipal sources highlight that mobile charging isn't really designed for the casual commuter. It is a vital stopgap for commercial fleets.
Ah, okay.
For example, the municipal notes point to Newton, Massachusetts. The city secured all these substantial grants to electrify their fleet of school buses.
Okay.
Right. Procuring the electric buses was easy. But the insurmountable bottleneck is the depot. They simply do not have a facility equipped with the massive electrical capacity required to charge a whole fleet of heavy-duty vehicles all at once.
Oh, wow. So they have this multi-million-dollar electric fleet, but they basically have to wait 3 to 5 years for the local utility to trench the concrete, upgrade substations, and, deliver the necessary megawatts to their depot.
Exactly. They are geographically stranded by the grid.
Which is where mobile charging comes in. It allows those fleets to electrify and operate right now. And we see this scaling up drastically with the press release from Pioneer Power Solutions.
Yeah, the e-boost system.
Right. They recently secured a $10 million multi-year award for their eBoost Pure Power 175 system. And this is not just a few batteries tossed in the back of a van.
No, not at all.
It's a deployable, off-grid, 180 to 500 kilowatt DC fast-charging hub powered by its own clean energy microgrid.
And just to put that in perspective for you, 500 kilowatts is enough power to juice up massive heavy-duty freight vehicles or a whole fleet of school buses in under an hour.
That's insane.
It really is. It is effectively a localized power plant on wheels.
Hmm.
And it establishes this entirely new industrial category referred to in the sources as MCIAS, mobile charging as a
And
service.
BSM, BeeCharged EV, is playing in that space too, right? They just secured major funding to expand their mobile commercial operations, deploying units equipped with both Level 2 and DC fast charging capabilities.
Yeah, and these deployable microgrids bypass the municipal red tape entirely. But the implications stretch way beyond just commercial convenience.
How so?
Well, when you introduce a heavy-duty off-grid power source that can move on demand, you're creating a foundational tool for emergency resilience.
Ah. Which brings us right back to the scenario we started with. If a severe storm or hurricane knocks out the regional grid, an EV is totally paralyzed. You can't, manually pump electricity out of an underground reserve tank like you can with gas.
Exactly.
SparkCharge actually put their mobile units to the test in Texas following Hurricane Beryl, deploying chargers to support stranded vehicles when the grid collapsed. And now, California is attempting to mandate this kind of emergency resilience by law.
Right. Assembly Bill 2543.
Yep.
And it's a piece of California legislation aimed at forcing emergency preparedness into the charging ecosystem. Now, we are examining the mechanics of this bill impartially here, right?
Hmm.
We're strictly looking at how it alters infrastructure independent of the politics surrounding California's broader climate policies.
Right, we're just looking at the facts in the text.
Exactly. The bill requires state agencies, specifically the Office of Emergency Services, Energy Safety, and the Energy Commission, to identify which direct current fast charging sites are critical to maintain during an emergency.
And the sources show they're determining these critical sites based on things like population density, geographical evacuation routes, and the distance between available chargers.
Yeah. And once a site is tagged as critical, the operator is legally required to submit an emergency management plan.
Oh, wow. So they have to detail exactly how they'll use backup power to keep those chargers online during like public safety power shutoffs or massive wildfires.
Yes. Whether that's on-site generators or deployable mobile charging units from companies like Pioneer Power.
Which is fascinating because the necessity of this bill exposes a massive blind spot in current federal regulations.
Oh, a huge one.
Yeah, the National Electric Vehicle Infrastructure Program, or NEV, mandates that publicly funded chargers maintain a 97% uptime. Basically, if a charger is broken for more than a few days a year, the operator is penalized.
Right. But here's the catch.
Yeah. The NEV metric explicitly excludes natural disasters or grid failures from that calculation.
Which is just a terrifying loophole if you're trying to evacuate your family.
Absolutely. A critical charging station on a major highway could be dead for 2 straight weeks after a wildfire destroys the local transmission lines, and the operator still hits their 97% federal uptime goal because the disaster doesn't count against their score.
It's pretty wild.
And AB 2543 is attempting to close that gap by forcing operators to actually prepare for the grid to fail. But here's what really stood out to me in the legislative analysis. The text explicitly acknowledges a glaring double standard.
Oh, with the gas stations.
Yes, traditional gas stations are not required by the state to have emergency plans or backup generators to stay open during a disaster. It's completely optional for them.
Right.
So why is the state putting a heavier, legally mandated burden on EV charging operators?
It's because state planners are fundamentally shifting how they classify energy delivery. Since EVs cannot store liquid energy in a jerrycan, right? They are wholly dependent on real-time electron flow. So public charging stations are no longer viewed as just commercial amenities.
They're critical infrastructure.
Exactly. They are critical public lifelines. If a mass evacuation is ordered and the grid goes dark, thousands of EVs stalling out on a highway doesn't just inconvenience the drivers, it blocks the entire evacuation corridor for emergency services.
But wait, if we expect an operator to run a multi-megawatt charging site off a backup microgrid for a week during a wildfire, the underlying battery technology has to change, right? I mean, standard lithium-ion batteries simply do not have the energy density to handle that kind of load without being the size of a commercial warehouse.
You're exactly right. The physics have to evolve. And that takes us into the highly technical research outlined in the NATO Energy Security Report.
Yeah, the NATO report, which is this massive deep dive into the bleeding-edge R&D driving these deployable microgrids.
Right, so current lithium-ion batteries are plateauing at an energy density of roughly 200 to 300 watt-hours per kilogram.
Okay.
To achieve the performance, safety, and capacity required for heavy fleet and off-grid emergency use, The industry is transitioning to solid-state batteries.
And just to break that down, in a traditional battery, the energy flows through a liquid electrolyte, right?
Yes.
But the NATO report highlights that solid-state batteries replace that highly volatile liquid with a solid ceramic material, which, from what I read, achieves two massive breakthroughs. First, it virtually eliminates the risk of thermal runaway.
Right. The battery won't catch fire if it's pierced or overheats.
Exactly, which is
Yeah.
crucial for safety during a disaster. And second, the solid ceramic allows ions to move much faster, drastically reducing charging times.
And alongside those solid-state ceramics, the chemistry of the anode itself is being radically redesigned.
Oh, the silicon anodes.
Right. Traditional batteries utilize graphite to store lithium ions. But the industry is moving towards silicon anodes, which have the potential to store roughly 10 times more lithium than graphite.
10 times the capacity is a staggering jump.
It is.
But, there is always a penalty in materials science. When silicon absorbs that massive amount of lithium during a charging cycle, it physically swells,
Yeah.
right? Expanding up to like 300% in volume.
Yeah, it inflates like a balloon.
And when it discharges, it contracts. So that constant mechanical stress fractures and destroys the battery from the inside out after just a few cycles.
Exactly. But researchers are mitigating that mechanical degradation using nanostructures.
Okay, how does that work?
By engineering the silicon at a microscopic level, they are essentially building a flexible molecular scaffolding, like a cage, around the silicon.
Oh, that's clever.
Yeah, this allows the material to swell and absorb the lithium without shattering the structural integrity of the electrode. And the report also highlights the development of sulfur cathodes to push capacity even higher while lowering manufacturing costs.
But it's not just about what the battery is made of, is it? It's about the software protocols governing what the battery can actually do.
Absolutely.
Because the NATO report heavily emphasizes the integration of V2G, vehicle-to-grid technology.
This is the real game changer.
Yeah, we are shifting away from the century-old model where a vehicle is purely a consumer of energy. With V2G bidirectional charging, an EV becomes a mobile bank account of energy.
Right. I mean, think about it. A vehicle sits parked for about 95% of its lifespan.
It's true.
Historically, that was just an idle, depreciating asset. Bidirectional charging redefines that entire relationship. During peak demand, say, a blistering summer afternoon when everyone turns on their air conditioning, the local utility can draw surplus electricity back out of parked EV batteries to stabilize the grid and prevent blackouts.
So what does that actually mean for you listening to this? It means every plugged-in car in your neighborhood essentially becomes a node in a decentralized neighborhood-wide power plant.
It's incredible.
It really is. And the NATO report goes out of its way to prove that this entire life cycle is becoming vastly more sustainable. We're seeing incredible innovations in closed-loop recycling from companies like Tesla's Redwood Materials and Volkswagen.
Yeah, Volkswagen utilizes a mechanical process they call black powder recovery.
Black powder?
Yeah, so instead of melting the batteries down in a highly toxic, energy-intensive furnace, they shred the old battery cells in a controlled, inert environment.
Yeah.
Then they use hydrometallurgy, basically chemical leaching, to sift out the raw materials. They recover up to 95% of the pure lithium, cobalt, and nickel, which can be spun right back into brand new batteries.
Wow, 95%?
Yeah. Life cycle assessments definitively prove that, even factoring in the intensive mining and manufacturing process, battery electric vehicles drastically outperform combustion engines in reducing emissions over their total lifespan.
Okay, so let's zoom out for a second. We have deployable mobile microgrids, legislation mandating off-grid resilience, ultra-dense solid-state ceramics, nanostructure silicon, and bidirectional vehicle-to-grid technology.
Right, all these puzzle pieces.
If you take all of those civilian innovations, where is the ultimate extreme proving ground to test them all simultaneously? It isn't a California highway or a lamppost in Massachusetts.
No, it is a military battlefield.
Exactly. The NATO operational energy concept is pushing aggressively for EV integration across tactical forces. And to be clear, this doctrine is entirely divorced from environmental goals.
Oh, completely. It is strictly about achieving a lethal tactical advantage.
Right, because an electric vehicle offers immense stealth capabilities. They have vastly reduced acoustic signatures. I mean, they are virtually silent compared to a roaring diesel engine.
Right.
But more importantly, they have a diminished thermal footprint. Internal combustion engines glow incredibly hot, making them massive targets for enemy heat sensors and thermal optics. And EV runs cool, making it significantly harder to track.
And you combine that stealth with the instant torque of an electric drivetrain,
Yeah.
and you have unmatched agility for navigating brutal off-road terrain.
Which is a huge tactical edge.
It is, and the tactical applications extend into the encampments as well. Utilizing that V2G technology we just talked about,
Yeah.
a military force can use their parked fleet of electric transport vehicles as a distributed backup power source to stabilize their own tactical microgrids.
Wow.
It is the realization of a core military doctrine outlined in the report, which they call energy superiority.
Energy superiority, which basically treats energy as a weaponized capability. You aggressively manage and control your own energy consumption while actively targeting and hindering your opponent's ability to use theirs.
Exactly.
But we have to ask the ultimate pragmatic question here. If everyday drivers get range anxiety driving to the suburbs, how does a military force plan to recharge a fleet of heavy-duty EVs in the middle of a hostile war zone where the grid has been intentionally blown up?
And that question connects every single thread of our deep dive today.
It really does.
The military is heavily monitoring and adapting the Mackays, the mobile charging, as a service breakthroughs from civilian companies like Pioneer Power and SparkCharge.
Oh, of course, yeah.
They are pairing those massive, deployable mobile charging hubs with the ultra-dense, fire-resistant solid-state batteries to ensure that expeditionary forces can bring their own microgrids directly to the front line.
So by deploying their own off-grid power hubs, they drastically reduce their reliance on incredibly vulnerable fossil fuel supply lines.
Exactly. I mean, convoys of diesel fuel trucks are massive, slow-moving targets that suffer heavy casualties in a conflict. Shifting to deployable, mobile electric microgrids changes the entire logistical math of warfare.
It is a complete reimagining of how power is generated, stored, moved, and deployed. The same underlying mechanical limitations driving a city to attach a charger to a lamppost are driving the military to rethink battlefield logistics.
It's wild to think about. We're basically witnessing the death of the stationary grid and the birth of a hyperlocal, decentralized, and entirely mobile energy ecosystem.
It's incredible how all these seemingly disparate sources lock together. I mean, we started by looking at the friction of getting a charge on a crowded city street without a driveway.
Right.
And the bureaucratic nightmare of the fixed grid led to the creation of massive mobile charging trucks acting as stopgaps for commercial fleets. Then, those deployable microgrids scaled up to become the backbone of emergency legislation requiring backup power for public evacuations. And surviving off-grid demands the next generation of solid-state ceramics and bidirectional vehicle-to-grid technology. And finally, NATO is adopting all of these civilian innovations to achieve ultimate battlefield energy superiority.
It's all connected.
It really is.
Yeah.
So based on everything we've unpacked from these sources, I want to leave you with a final scenario to mull over. If bidirectional vehicle-to-grid technology becomes the standard method for ensuring emergency grid resilience, will there come a day when a city facing a catastrophic blackout can legally require your plugged-in car to drain its battery to keep the local hospital's lights on? What happens to your morning commute or your evacuation plan when your personal vehicle gets drafted into the public power grid overnight? Something to think about the next time you plug in.